Hello students, welcome back to the another video lecture of ADA subject. In today's video lecture we are going to learn about minimum spanning tree. Okay, so without wasting time, let's start with meaning of spanning tree. A spanning tree S is a subset of a tree T in which all the vertices of tree are present, but it may not contain all the edges. Okay, so in your spanning tree we will generate a subtree of that actual tree in which all the vertices, means all the nodes will be there, but some of the edges may be lost for generating this subset, means for generating this spanning tree. Okay, so minimum spanning tree is a spanning tree where all the nodes are remain connected with minimum cost. If we have vertices connected with the edges of various weight, then minimum spanning tree will have only minimum cost weight to connect one another. Now applications of minimum spanning tree are: first application is minimum spanning tree are very important in designing efficient routing algorithm, and second application is they have wide application in many areas such as network designing. This network designing issue we will understand by an example. Okay, so now there are two algorithms to find minimum spanning tree. First algorithm is prim's algorithm and second one is kruskal algorithm. We will understand first prim's algorithm. So prim's algorithm will have mainly three steps. First step says we have to select the pair with minimum weight. Second step states select the adjacent vertices and select the minimum weight edge using this adjacent vertex. The selected adjacent vertex should not form the circuit. That is the very essential condition for the prim's algorithm, that vertex should not form the circuit. Okay, after it, third step says we have to repeat step and 2 until all vertices are getting covered. Okay, so let's understand that by an example. So this is an example of prim's algorithm. In that we have a graph with total 6 vertices and different edges with that 6 vertices are connected. Okay, so here we have A, B, C, D, E and F, 6 vertices here. A and B is connected with 16 weight, B and C is connected with 6 weight, E and D is connected with 18 weight, F and E is connected with 33 gap. So we have to find out all the vertices with the minimum weight. So for finding that minimum weight edges, we have to perform this algorithm. This algorithm says we have to select the pair with minimum weight. So we will select this pair B and D with weight 5 because this is the minimum weight in this total graph. So here B and D will have minimum weight in this graph. After that, our second step says we have to select adjacent vertex and select the minimum weight edge using the adjacent vertex. Okay, so here in this figure with B and D, our adjacent vertex are A, F, E and C. Means we can connect B to A directly. So A is adjacent vertex of B. We can connect B to F directly. So F is the adjacent vertex of B. We can connect E to D directly. So E is also an adjacent vertex. We can connect B to C directly. So that is also an adjacent vertex. We can also connect from D to C. So from all of this we have to find out adjacent vertex as well as minimum weight. So from the all weights we have minimum weight is 6 with the adjacent vertex C here. So we will check and select C as the adjacent vertex of B. Now our third step says again we have to select adjacent vertex with the minimum weight. So now with the B, D and C adjacent vertices are B to A, B to F as well as D to F and D to E. So we have to find out minimum weight edge. So from all of this our minimum weight edge is 11 and adjacent vertex is F. So we will select F here with the weight 11. Now from the B, C, D and F we can connect A by 3 ways, 1, 2 and 3. We can also connect E with 3 ways, 1, 2 and 3. So we will find the minimum weight. So from the all here we can find B to A with 16. Now B to F we have already taken. So from F to A that is 21 weight. From F to E that is 33. From D to E that is 18. So from all of this we can find that minimum weight is here 16. So we will connect our B to A with the 16 weight. Here a concept that why we are not connecting D to C with 10 weight, why we are not connecting F to D with 14 weight. So here our this second step says we have to connect with the adjacent vertices with minimum weight as well as the selected adjacent vertex should not form the circuit. Okay, so in this figure if we connect D to F with 14 and as well as we connect B to F with 11, or we select B to C as well as C to D, then that will form a circuit here. So avoid that circuit condition, we will not select that edges which forms the circuit. Okay, so now in this figure our remaining vertex is E. To connect with E we have 3 different paths, A to E as well as F to E as well as D to E. So from 3 paths we have minimum path is D to E and with the 18 weight. So we will select this path and we will select E vertices. Okay, so here this is the solution, or we can say this is the minimum spanning tree from the Prim's algorithm. Okay, so this is the one example for forming a solution, or we can say to find a minimum spanning tree from a graph, or we can say from a tree. Now this is the second example for minimum spanning tree with using Prim's algorithm. So here we have 1, 2, 3, 4, 5, 6, 7 vertices and different edges here. So we will have to select edges on the base of Prim's algorithm, and after it we will have to draw a minimum spanning tree of this tree. Okay, so after selecting 5 we will select adjacent matrix B. After it we will select edges 8, 9, 11, 8, 15, 7. So minimum weight is 7, so we will select this thing. After it we will select adjacent matrices, this. After it we will select this F6 matrix, and after it for connecting G we will select this edge as 9. Or we can start from the A to D vertices. Why? Because A to D is minimum cost is 5 and also A to C is minimum cost is 5. So we can start from the any edges with the minimum weight. Okay, so there is no issue for selecting A to D first or selecting C to E first. We can start from the any edges, but our resultant tree must be minimum spanning tree. Okay, so for this figure our minimum spanning tree will be E to C, that is 5. After it we will select 7. After it we will select our next 7, which is this. After it adjacent vertices are D, F and G, but here E to D is 15, B to D is 9, A to D is 5, so minimum is 5, so we will select 5. After it D to E is 6, E to G is 9, so we will select D to F as 6. After it we have two paths, E to G and F to G. One's weight is 9 and another weight is 11, so we will select G with the minimum weight. So this is the solution of this figure, and the minimum spanning trees total cost will be 39. This is also an example of Prim's algorithm. From this figure we have to find a minimum spanning tree with the all vertices and some selected minimum weight edges. So that will be a question for you guys. You will have to solve this figure and you will have to find out what are the vertices and what are the indexes, or we can say edges, with the minimum weight. Now let's learn about Kruskal's algorithm. So as like Prim's algorithm, Kruskal algorithm also forms the minimum spanning tree, but its algorithm is somewhat different than Prim's algorithm. So let's understand what Kruskal algorithm says. So its algorithm first step is select the pair with minimum weight each time and make the union of selected edges. Okay, so that is the difference. We will have to select pair with the minimum weight each time and make the union of selected edges, where in Prim's algorithm we were selecting the minimum weight edge first time and after we were selecting the adjacent vertices of that weight. Okay, so now we will select each and every time different vertices, or you can say different vertices with the minimum weight, and after it we will do union of that selected edges. Then the selected edges vertices should not form a circuit. So again that condition is also applicable here. We do not can make a circuit in our example. After it, second step says we have to repeat step 1 until we found our minimum spanning tree. Okay, so that is the question in this figure. We have total 7 vertices in this figure with the different edges weight, and we will have to found the minimum spanning tree from this thing. Here you can see here weight is 1, here 2 weight, 2 times 3 weight, here 2 times 4 weight, here 2 times 5 weight, and 2 times 6 weight is here. So first of all we will select vertices V0 and V2 with the minimum weight edge 1. After it we will select minimum weight edges with 2, which is V0 to V1 and V3 to V6 to V5. So in that case, if we are using Prim's algorithm, then we have to select V0 to V1. But if we are using Kruskal's algorithm, then we can select any of these edges. We can select V0 or V1, or we can select V5 to V6. Okay, so that is the main difference between Prim's algorithm and Kruskal's algorithm. Okay, so now let's understand one example with the Kruskal's algorithm. So that is the same example that we have solved by Prim's algorithm. So its solution will be look like this. But let's consider this case. So this case will be solved by kruskal algorithm. So for solving this thing, first of all we will select the edge with the minimum weight. So we have E to C is the minimum weight with the vertices C and E. Now our kruskal algorithm says you have to select minimum weight edges, and after it we will have to do union of that edges. Okay, so after selecting this edge C2E5, we will have to select edge with the minimum weight. So minimum weight is also of A to D, which is already 5. So we will select A to D vertices. After it, we will check the minimum weight from all the edges. D to F is minimum with the 6. So we will select D to F. Sorry, D to E not, but it is D to F. After selecting F, we will find that from these vertices, or we can say this edges, minimum weight is 7. Okay, so now we will get A to B with the 7 weight. Now we will find that from the edges 8, 9, 7, 15, 11, 9 and 8, minimum weight is 7. So we will connect B and V with the edge 7 with the weight 7. Okay, so now our remaining edges is 9, 15, 8, 11, 9 and 8. So from all of this, minimum weight is 8, but we cannot select 8. Why? Because with selection of 8 edge, we will form a circuit, or we will have a circle here. So that is the constraint, that we cannot create a circuit in our minimum spanning tree. Okay, so after it we can select 15 again. So 15, 9, 11, 8. So all these things will form a circuit. So we cannot select that edges which can create a circuit in our tree. So we can select 11 or 9. With that thing we will not have a circuit in our spanning tree. So from E to G weight is 9, and from F to G weight is 11. So from both of them our minimum weight is 9. So we will select 9 edge with the minimum weight. So that is E to G. So this is the solution of this program by Kruskal's algorithm, and after it solving, our minimum spanning tree's weight will be 39. Okay, so now let's understand what is the difference between Prim's and Kruskal's algorithm. Okay, so difference you will have to find out from the algorithms of Prim's and Kruskal's algorithm. Now let's understand an example which I have already asked in your summer 2014 examination of 7 mark. That says there is a network given in the figure below as a highway map, and the number of recorded next to each arc as the minimum elevation encountered in traversing the arc. A traveler plans to drive from node 1 to 12 on his highway. The traveler dislikes high altitude and so would like to find a path connecting node 1 to 12 that minimizes the maximum altitude. Find the best path for the traveler using MST, means minimum spanning tree. Now we can use graph to be drawn from Kruskal or Prim's algorithm for minimum spanning tree. Okay, so this example says that there are 12 total number of vertices and different edges which connect that 12 vertices. After, or we can say from that 12 vertices, we will have to form a minimum spanning tree with using Kruskal's or Prim's algorithm. Okay, so that is a very simple question. Let's solve this example. Okay, so if we select a Kruskal's algorithm, then we will find out that from this figure our minimum weight is 1 and from A to C vertices. Okay, so first of all we will select edge A to C with 1 weight. Okay, so in step 1 we have selected vertices A to C. Okay, if we are using Prim's algorithm to solve this, then we will select adjacent edge of A and C with the minimum weight. So from A and C, adjacent vertices are G, D and B. If we go from A to B, then 7 weight is here. If we go from A to D, then 4 weight is here. If to go C to D, then 5 weight is here, and if we go from A to G, then 3 weight is here. So we will select 3 as a minimum weight, so we will connect C to G. After it, minimum weight is here from G to J, so we will connect from G to J. After it, we will select this A to D with the 4. After it, we will select D to H with the 2. After it, we will select adjacent node E with 5 weight. After it, we will select adjacent node I with the 3 weight. In step 8, we will connect with the F 4 weight. We will connect for I to K with the 7 weight, and in last we will connect with our 12th node, which is L with the 6 weight. So this is a solution using Prim's algorithm. Now the question is that if you want to solve this example by Kruskal's algorithm, then what will be the steps and what will be the solution after finding minimum spanning tree using Kruskal's algorithm? Okay, so solve by yourself using Kruskal's algorithm and state that what is the cost of minimum spanning tree of this graph using Kruskal's algorithm. Okay, so this is it for minimum spanning tree and two algorithm, Prim's and Kruskals. If you like this video, then like, comment and subscribe. Also share it with your friends. Thank you friends.